Okay, good morning. So I start teaching you, but I have a little bit of pain in my legs, so hopefully this works fine. In the other classes, it works fine. So after the lesson is finished, I can also publish the PDF file of the class notes, as well as, so I have set up something to record, but unfortunately, because the quality of this monitor is not that perfect, it's not HD probably, but it is manageable. So hope you can see how is it going. Okay. So let us start solving the problems we had before. So let me just review a little bit. Yes. So here, if you remember, the problem we had was like this. So I give you a function. Yes, is that visible for you? Yeah, if this is too small, you can come a little bit in front. So I give you a function which is continuous, and I give you an interval which is closed. What do I mean by having closed intervals? I mean that you have both endpoints included. Yes. So how do we find the maximum and minimum on a continuous function on a closed interval? Sometimes people emphasize on that by saying absolute maximum and minimum. Okay. How we can do that? If you remember, if I have a continuous function and my interval is closed, meaning that it includes both endpoints, then it is guaranteed by a mathematical theorem that such a function has a maximum and minimum on this interval. But if you remember, the recipe of determining this maximum and minimum was to calculate the derivative of the function first, equate it to 0, solve that equation and find x's which belong to this interval, and then calculate the value of the function for those points we found, and then we also need to calculate the value of the function at the endpoints. Then we get a bunch of numbers. The highest value in that list is the maximum and the lowest value is the minimum. So this is different from finding the local extreme points, local maximum and local minimum. For local maximum and local minimum, after finding derivative and finding the roots of the derivative, we have to make up a sign table, and using the sign table, we can actually find the maximum and minimum. Okay, so let me refresh your memory by solving these two problems. We can work together, okay? So let me, if you don't mind, let me split it into two parts so that, we have enough space. So for the first one, if I want to solve number 1, so what I do, I take the derivative of my function. The derivative of this function is extremely simple, so it is 3x squared minus 6x plus 0, that's it. And then what I do, I put the derivative equal to 0 and solve the problem. So if I put the derivative equal to 0, what do I get? I get 3x squared minus 6x equals to 0. And then this is simple to solve. Yes, so let me solve it here. I factor a 3x out, and I am left with x minus 2 equals to 0. So I get two values. One value is 0, and the other value is 2. Are both of them are acceptable? You have to be careful. Are these two numbers in the interval given? Yes, both of them are there. So let me put them in a box, so it means that they are acceptable, yes? Okay, now after I found these, I got two acceptable points from solving this equation, and I have two endpoints. So in total, I have 4 points to calculate. So what I do, I calculate the value of my function at 0. Yes, 0 is one of these numbers, so I go to the original function and replace x with 0. What do I get? I get simply 2. I calculate f of 2. 2 is the second number I got here. It means that I go to the original function, replace x with 2. So this becomes 8 minus 12 plus 2. And if you solve it, it becomes minus 2. But I also have to calculate f of minus 1. Minus 1 is one of the endpoints. I have to calculate that. So I replace x with minus 1. So this becomes minus 1 minus 3 plus 2, which becomes minus 2 again. And then I have what? I have f of 3. But if I calculate f of 3, it becomes 27, so it becomes 2. Oh, that's an extreme question. Okay, so what do I get? I get 4 numbers. They are repeating themselves. Oh, I remember, so I constructed this example intentionally like this, okay? So these are the numbers that I get. Okay, so for the first part of the problem, that the interval is closed, you don't need to be worried. You have a list of 4 numbers. They are the same 2 by 2. So if I ask you what is the maximum of f, you can immediately answer. So what is the maximum of f? What is that? It's 2. And what is the minimum of f? It's minus 2. Yes, that's for sure. Okay, and then if I ask you where the maximum is achieved, where the maximum is achieved when x is 0 or when x is 3. So it means that I get this number 2 at 2 different points. One at the internal point 0, 0 is within this interval, and the other one is the end point. So the function reaches to that maximum at 2 points. One is within the interval when x is equal to 0, when another time when x is 3, which is the final end point. But the maximum value is just one single number, yes?
Wait, I mean, don't catch me. Yeah, I must have cut.
Are they?
Sorry, oh no, okay, sorry.
Okay. Now, what happens here? What do you think it will affect how the calculation goes for the next interval? So the next interval x is between minus 1 and 3, but this time I am excluding 3. Okay, when I exclude 3, this means that this number is gone because I am not allowed to put 3 there. So then I get 2 numbers, minus 2 and minus 2 and 2. Okay, but is the maximum still 2 and the minimum is still minus 2? Yes or no?
Yes.
Yes. Because even though 3 is gone, 3 will take away these 2, but there is another 2 in my list, and there are 2 minus 2's in my list again. So still the maximum is 2 and the minimum is minus 2, even if one of them is closed. It's open, yes. Is that clear? Yes or no? So for both of them are actually maximum and minimum are 2 and minus 2. But sometimes it will change the result, you know. For example, if I had here, if I had 1 here, and if I had 2 here, the maximum is 2 and occurs at 3. When I take 3 away, the maximum is gone with it. Yes? So you don't say that the maximum is now 1. Be careful. Do you understand that? As for example, if I have this shape, I don't know, let me just draw a random picture here. So if you have something like this, assume that here is 3 and the highest value is 5. Okay? So can I say that if I take 3 away, the maximum is somewhere here? No, because if I take 3 away, the maximum is gone. There is no maximum for the function. Yes, so you have to be careful. So you cannot say that, okay, if I delete this, still this is my maximum. Is that understandable? So you have to visualize it from geometrical points of view. Okay, so now let us go to the second question. So the second question is more or less the same thing. Let us see how we have it here. So I have a continuous function again, because this part is polynomial. this part is exponential, both of them are continuous, so the addition of two continuous functions is still continuous. But my interval is one part of it is closed, one part of it is open. One part is included, one part is not included. So let us see how this will go. Okay, so the first step is to do what? To take the derivative again. So what is the derivative? So the derivative is, it is g prime, sorry. So g prime of x is equal to, I have e to power x minus 3. Yes? And then what I am supposed to do, I put the derivative equal to 0 and solve this equation. So e to the power of x minus 3 becomes 0. So this means that e to power x is equal to 3. Okay, can you tell me what x is? ln of 3. So this is one number that I get, but is it acceptable? In other words, is this number within my interval or not? Of course, if you have calculator, you punch this in your calculator and you realize that. But I think if you don't have calculator available, is it true that, first of all, ln of 3 is definitely positive, yes? How should I know that? How do you know ln of 3 is positive? No, logarithm can be negative. What is in front of the logarithm cannot be negative. The output of a logarithm can be negative. For example, log of 0.1 is negative 1. Because 10 to power minus 1 is 0.1. What you put in front of a log cannot be negative, but it doesn't guarantee by itself that the output is also non-negative. Okay, but why ln of 3, which is logarithm of 3 in base the Euler number? Why this number is positive?
3 is bigger than 1.
Yes?
3 is bigger than 1. And that's when the output of y switches from being positive to negative.
3 is bigger than 1, yes? So that's the reason. Because 3 is bigger than 1, but of course e also is bigger than 1. You know that a is something, yes? So if this is going to be negative, so let us say this is x, then e to power, by the way, you can immediately see that. Is it possible x to be negative? No, because if x is negative, e to power of a negative number, whatever it is, let me write this. This is 1 over e to the power of a. This becomes a smaller than 1. There is no way for it to become 3. So x has to be positive. But, for example, can x be 2? No, because e is around 2.7. If x is 2, 2.7 to power 2 is even bigger than 3, yes, let alone larger than that. So definitely this number is a positive number, and it is also definitely less than 2, yes? So it is in the interval. Okay, so this is acceptable solution. Because I told you that when you differentiate and put it equal to 0, what you need to find a number, and then you need to convince yourself if this is the case that it belongs to my interval, in my interval group. Hopefully you agree with me that ln of 3, even without having the calculator available, is definitely within this interval. Yes? Everyone agrees? Okay. And then what I'm supposed to calculate now, I am supposed to calculate g at this calculated value. I have to calculate g. By the way, I have to calculate the g at the endpoints, even if this endpoint is not included. So I calculate g of minus 4. I also calculate g of 2. Okay? But if the maximum and minimum is supposed to occur at this point, because this point is excluded, then the maximum or the minimum does not occur. It doesn't have any maximum or minimum. So that's the only point. Okay, so how can I calculate g of minus 3? G of ln of 3. So I should replace the x with ln of 3. So it becomes e to the power of ln of 3 minus 3 ln of 3 minus 2. Okay, but what is the value of this one? Without calculator, what is that?
3.
It is 3. And then I have a minus 2 here, so it becomes positive 1. So this becomes 1 minus 3 times ln of 3. We have to keep it like this, assuming that we don't have calculator available. So one number is actually this number. Another number is what? G of minus 4. So it becomes e to the power of minus 4, and then plus 12 minus 2. So what I did, I replaced x here and there with minus 4. And when I calculate that, it becomes 10, because 12 minus 2 is 10, and plus e to the power of minus 4, I can write it like this. Okay? And g of 2 is e to the power of 2 minus 6 minus 2, which is e to power 2 minus 8. So these are a little bit, not friendly numbers, but these are the values that we get. Okay, do you think there is a map? But be careful about 2, because even though I calculated 2, but 2 is excluded here. What does it mean? It means that if this is the maximum, or if this is the minimum, this function on the open interval does not have any maximum or minimum correspondingly. So that should be the interpretation. Okay, so what do you think? Which one is the highest value? Yes?
10 plus 1 over e to the power.
It seems so, yes, because definitely this is a negative number. Do you agree? Yes, so that's a negative number. Okay, and that is a positive number. So between these two, definitely this will win. This is more positive. But what about this one? This is also unfortunately negative. Yes. So the maximum, we don't have any doubts. Yes, the maximum is this number, and it occurs at minus 4. Unfortunately, minus 4 is included. So this is the end of the story for maximum. So maximum of g is 10 plus 1 over e to the power of 4. But which one is bigger? So is e to the power of 2 minus 8 bigger, or 1 minus 3 ln of 3? Because both of them are negative. Yes? Yeah.
I would have to guess e to the power of 2 minus 8.
But yes, I don't know. Are you? So that's what I'm saying. Should either should be lucky, or we should go and understand what's going on. Yes.
Since e is like around 2.7 to the power of 2, which like 60, it should be around 8.
Okay, so let me tell you something. If I want to do this, so let me just do the calculations here. Yes. So what I do, I will actually choose a random sign for myself. What do I mean? So I would say that, okay, let us assume that this one, I don't know, what is your feeling? Is it smaller than e to the power of 2 minus 8, or the other way around?
Smaller.
The smaller. Okay, so I choose a smaller, as you said. But then I try to simplify this in a recursive way. Okay, so it means that if this is going to happen, this is equivalent to. So what I do, I, for example, move this one to the other side. Or let us do that. Let me move these to the left, and let me move this to the right. I don't know. So what happens, it becomes 9 minus e squared is less than 3 ln of 3. So do you agree that? So what I did, I moved e squared to the left. I moved minus 8 to the left. It becomes positive 9, and then I move this to the right. Okay, so might be this is harder guess, but this is recursive. It means that these two statements are equivalent. So if this is true, this one is also true, and vice versa. Okay, is it easier to guess in this way?
Yeah.
Yes or no? So for example, let us continue. So let us continue a little bit if that's not easy to guess. So 9, this one. And then do you remember, I can put this 3 on top of this 3, it becomes ln of 27. Yes? But is it trivial that this is true? If not, you continue, yes? So what do I mean? So you can say that e to the power of 9 minus e squared should be less than 27. But is that right?
No.
Do you understand what I'm doing?
Oh, no,
I just followed what you said. That was your intuition that 1 minus 3 ln of 3 is less than e squared minus 8. I started with your guess and started simplifying the inequality in a recursive way. What do I mean by recursive? I mean that if I can go from here to here, I should also be able to go back. So every operation that I have done is recursive. So this means that there is no difference between the truth and falsity of this inequality and the truth and falsity of this inequality. But might be this is hard to guess if it is true or false, but this might be easier to guess. But do you believe that this is true or not? Do you really believe in that?
I believe in that.
No, because e to the power of 2 is how much?
it should be like
It should
2 point, it's like around 2.7 to 2.7, so that's
like
like
slightly less than 9.
It is less than 9, but how much less than 9?
Yeah, I
it
guess.
should be very close to like 8. Or
So this is a
I mean,
pretty damn close number, so might be it is not easy to guess, yes? So because so how can we understand that without calculator? So do you have any rough estimate of 2.7 to power 2? Yeah.
1.4 plus 1.
7.8.
So it should be around, yeah, exactly.
What?
7.8.
Okay, so if that is 7, then probably this guess is correct, yes? We can check that. So, I mean, so what you're saying is that 9e to the power of 2 is less than 3, yes? Do you think that this is true?
Oh,
Yes? But if that is true, then we are done. Because what we say, this means that e to power 2 is greater than 6. Is e to the power of 2 greater than 6?
yes.
Yes, because 2.7 to the power of 2 is definitely greater than 6. Okay, and if that is the case, it means that 9 minus e squared is less than 3. Do you agree? If that is the case, it means e to the power of this one is less than e to power 3. And e to power 3 is less than this 27. Is that right? Because 27 is 3 to the power of 3, and e is less than 3. So yes, so your guess is correct. Yes.
How rigorous is this argument?
No, this is very rigorous, except the only thing that we didn't check really is that e squared is less than 6. But that's completely rigorous.
But like you're not using the exact value of e squared, but you.
No, we don't need, that's the point. The only thing that we have to be certain about is that e to power 2 is less than 6. You might say, how rigorous is that? Yes, I didn't do that rigorous, but I can check. Yes, as e to the power of 2 is greater than 6. If that's true, whatever I said is completely rigorous. There is no approximation going on. Okay. So anyway, so your guess was correct. So what is the minimum then? Minimum is this number. And is it acceptable? Yes, because it occurs at an internal point. So what happens is that the minimum of g is exactly 1 minus 3 ln of 3. But of course, this problem looks a little bit hard because you're not allowed to use the calculator. But if you want to use the calculator, you just punch the numbers there and compare them. So that's not a hard problem. Yes?
But isn't 2 excluded?
No, it doesn't happen at 2.
But I thought you said because 2 is not part of our integral here.
No, because e squared minus 8 is not the minimum.
No, yeah.
The minimum is this one, and it occurs here, and it is acceptable. It is within the interval.
Okay, so if
Yes, if this was the other way around, if e squared minus 8 was smaller than that one, then you have to choose this one as the minimum. But in that case, this cannot occur because 2 is excluded from the interval. That's what I'm saying. Then you will say that the minimum does not exist. Yes? Is that clear? Okay. Okay, so the next part of the lesson is actually optimization problems. So if you have, I don't know, a fixed amount of resources and you want to optimize something. For example, if that is your money or profit, you want to maximize it. Optimization here means maximizing. Or on the other hand, you can minimize your loss. Both of them are actually optimization, yes? So there is nothing new in this lesson. And so the problem is exactly as the previous problem, but the point is that in this case, you have to write the function yourself and you have to know the interval yourself by reading the text. And then if you have the function and if you have the interval, the problem is exactly as before. So the recipe is as like this. Is that clear? So here we want to optimize something. Sometimes optimizations means maximizing something, or sometimes it means minimizing. Yes, the best example is probably according to the money. If you care about profit, you want to maximize it, this is your optimization problem, and you can simultaneously minimize your loss. That is also optimization. Yes? Okay, so let us try to solve these problems. And I think that some students find this a little bit hard. Sometimes they are really harder because you need to find the function yourself. So that's the hard part. Okay, but let us start with some simple problems. So let us read the problem. A wire 16 meters long has to be formed into a rectangle. So I have a, I don't know, 16 meters long cable. I want to bend it and form a rectangle. Yes? What dimensions should the rectangle have for the largest area? So that's an optimization problem, yes? Because you are not supposed to change the length of the wire. Yes, the length of the wire is fixed. You want to use it in the best possible way. If best possible way means enclosing the largest area. Yes? So we want to see in which way we should bend the wire to make a rectangle so that the area enclosed by that is the largest possible value. So the problem is very clear. But what you need to do, you need to come up with a function yourself and an interval yourself. Okay, so let us try to think a little bit how we can think about the problem. So assume that this is the rectangle that I make, yes? Yes, assume that this is the rectangle that I make. And I know that the perimeter of this rectangle is supposed to be 16 meters. But I am flexible in how to choose the length and how to choose the width. Okay? Okay, so what we do, we say that, okay, the length, let me call it x. Okay, the height, let me call it y. What is the target function? Which quantity you are going to optimize? Here you want to maximize which? Yes? Area. Yes? That is your target. So you set up a name for it. For example, it is common to call it A because of area. And if I ask you what is this area, you will tell me that area is the product of these two numbers. So the target quantity is the area, and you wrote a formula for it. That's good. But the point is that in this formula, you have two variables, x and y. If I want to differentiate a function, which is necessary for this case, I have to have one single variable. So I have to eliminate one of these variables in favor of the other one. And that is where you have some piece of information here. So you know that the total length is supposed to be 16. So what do you know? So you know that if I add x plus y and multiply it by 2, it is supposed to be 16. And if I divide everything by 2, so x plus y is 8. And then, for example, if I use this constraint equation to eliminate y becomes 8 minus x. And then what I can do, I can go back to my target function, replace y with 8 minus x. Then I have a function of x only. Here I have a function of two variables apparently, but when I do that, I get a function a, which is x. Instead of y, I put 8 minus x. And now I am allowed to call it a of x. Yes? So here you can say that a is a function of x and y. This is not at the level of your lesson to want to talk about, we have to write it in one variable. So now I have my function. Yes, so I have to maximize this function. But I also need an interval. What that interval is? Yes?
Yes, like between 8 and 0, but 8 and 0 are excluded.
8 and 0, you can include it. It doesn't matter, but that would be an extreme case. There is no rectangle. So there is no problem. So you priori, you know that the maximum of this function will not occur at 0 at 8. Yes? So yes, let us give it this. So I would say that x is minimally 0, but of course, x cannot be really 0, because if x is equal to 0, it means that I have just a vertical line. Yes? And at most is 8. Yes? Again, if x is 8, it means that I have just a horizontal line. Yes, is that clear? Okay, so you see that this problem even is simpler than the previous problem. But you have to analyze the problem in a way that you can find a target function of one variable, and you should have also an interval. Yes? Okay, so what is the recipe? The recipe is clear. You have to differentiate the function. You have to calculate the value of the function at the values that you find, and you also need to calculate the value of the function at the endpoints. Yes? Okay, so how can I differentiate ax?
Well, I would expand.
Yes?
Simplify it before.
Yes, we have to expand, because of course in Math 4 you will learn how to attack the problem directly by the product rule, but you haven't studied that here. So a of x is equal to 8x minus x squared, and then I differentiate it. So this is simply 8 minus 2x. I put it equal to 0. What do I get? I get 8 minus 2x equals to 0, so x becomes 4. Is 4 acceptable? Yes, because 4 is within this interval, so it is acceptable. So how many values I have to calculate in principle? Of course, you know that the endpoints will give result to 0. The area will be 0 if I have just a horizontal line or a vertical line. But technically speaking, we calculate them. So a of 0, I put 0 here. Instead of my area x, it becomes 0. I calculate a of 8. What happens? I put 8 here. Again, the result is 0. It was predictable in this problem. And then I calculate a of 4. If I calculate a of 4, I put 4 here. It becomes 4. I have another 4 here. Multiply them, 16. And then everything is expressed in meters. So this is extremely important to write the units. So there are two types of questions. What is the maximum value? I don't know what is asked here. This is not the answer to the problem, because in the problem they have asked what dimensions should the rectangle have for the largest area. This is the largest achievable area by this. Okay, but what dimensions I should have for my rectangle? Yes, 4 and 4. So in principle the rectangle should be square. And that's actually a very famous fact, that if you want to maximize your rectangle, among all quadrilaterals with the same perimeter, a square has the largest area.
But is it a rectangle if it's a square?
Yes. Square is kind of a rectangle, not rectangular is a square. A square is a particular case of a rectangle. Yes? So is that clear? So this is the simplest possible example about optimization problems. But the ideas are all the same. So you read the text, you just give the target function a name and try to write an equation for it, and then try to use, if there are more than one variable, try to use the information given in the problem to eliminate that extra variables and then do the problem the same. So let me just do another example here. Okay, so let us read. Among all pairs of non-negative numbers that add up to 5, find the pair that gives the largest value for the product of the square of the first number and the cube of the second one. Okay. So what should we do? So let us read the problem again. Among all pairs of non-negative numbers that add up to 5. So I have two numbers, let us call them x and y. So x plus y is supposed to be 5. How many? And then x and y are both non-negative. This is what is mentioned in the problem, yes? How many pairs you have here satisfying this condition?
Infinitely.
Infinitely many, because you can also consider decimals and every number. Okay, among all these pairs satisfying these constraints, we want to find that pair that gives the largest value for the product of the square of the first number and the cube of the second number. So what does it mean? It means that I have a function, let me write a product p, which is x to the power of 2, the square of the first number, for example, let us say x is the first number, multiplied by the cube of the second number. So my target is to maximize p. Yes? So how should we solve the problem?
We need to eliminate one of the variables.
Yes, because you see the target function is already a product of this x to the power of 2, y to the power of 3, but there are two variables there. I have to eliminate one of them in favor of the other one. By the way, now algebra matters. In technically speaking, it doesn't matter which variable you are supposed to eliminate. It will work, but might be from practical reasons, one of them is more comfortable than the other one. Before doing that, I really extremely recommend on that. Before just doing things randomly and quickly, think a little bit. If you are supposed to do that, which one do you want to eliminate? Do you think it is algebraically easier to eliminate y in favor of x or eliminate x in favor of y?
X in favor of y.
X, y?
Because it's squared. So
It's a squared, yes? Do you agree? Because if you want to do that, then you have to raise something to power 3, which is harder. So that's good. So what we do, we actually here, we say that x is equal to 5 minus y. Yes? And then I put this here instead of x. So then p becomes equal to what? 5 minus y squared and y cubed. Now I can simply call it a function of y. So let me make it clear. So this is a function of y only. Okay, is there any interval involved in that problem? One part of the interval is clear. It's mentioned in the problem that y is non-negative. Okay, is there any upper bound for my y? Yes?
Can be bigger than 1 or 5. I mean.
Bigger than 5, yes? Because x is also non-negative. Yes? Because it is mentioned both x and y are non-negative. Yes? And you see that x is, so here, if y goes beyond 5, because the sum is supposed to be 5, x has to be negative, which is not acceptable. So the maximum value of y is 5. Yes? So you see, in the previous problems, I have already given you the function and the interval. But here, there is one more step. Sometimes it is hard. You need to find the function yourself. You need to find the interval yourself. As soon as you have both of them, you can do the problem as before. But here, we have to differentiate the function. So what is your suggestion? Expand. So this becomes 25 minus 10y plus y squared times y cubed. So if I go and do it once more, so it becomes 25y cubed minus 10y to the 4 and then y to the 5. Hopefully we can manage to solve it, okay? So then taking the derivative is what? It is 75y to the power of 2 minus 40y to the power of 3 plus y to the power of 4. Do you think we can manage to solve it? It's a 4th degree polynomial.
we can factorize it.
We can factor a 5 and we can factor a y squared.
Yeah.
Yes? So if I put p prime of y equals to 0, I can factor a 5, I can factor a y squared. So what is left from the first one is just 15. And then 8y. And the other one is what? Y to the power of 2. Am I right? Okay, so this gives me either y is equal to 0. Is y equals to 0 is acceptable? Yes, it is acceptable, but It is just an endpoint, so it doesn't matter. Either I choose it here or there. Okay, but then I have to put this one equal to 0 as well. So this means that y squared minus 8y plus 15 is equal to 0. Either you use ABC or PQ formula, but I think factorization is simple here. Can you guess the factorization? I need two numbers whose sum is minus 8 and the product is positive 15.
Minus 3 and
Minus 3 and minus 5. Yes. So what are the answers? The answers is 1, 3, and 1 is 5. And again, 5 is not that important because that's also an endpoint. So the only point that we get to check is in principle that one, and of course the endpoints 0 and 5. Okay? But calculating P of 0 is extremely simple. What's the answer? It's 0. Calculating P of 5 is also simple. What's the answer? Again 0, yes, because I put it here. If I put y equal to 0, P of y is 0. If I put y equals to 5, it is also 0. So the only thing that I have to check is P of 3. So what is P of 3? It is 3, it is 5 minus 3, 2, to the power of 2, 4, 3 to the power of 3, 28. Multiply them is 100 and, 100 and what? So 40, 32, 112, yes? Yes.
3 to power 3, 27.
27, yes. Yeah, it is, okay, sorry. It's 27, and then it is what here? It is 4. So it's 108, thank you. So it is 108. What is wanted in the problem? What is the largest value? So what's the largest value? 108. Here we have to answer the largest value is 108. But if someone asks you for which pair I achieved the goal 108, what is that pair?
3 and 2.
Yes, 2 and 3. Yeah, it was.
Isn't that a question?
Pardon?
Find the pair that gives largest value.
Okay. Yeah, thank you. So that's not this one, yeah. Thank you. So that's the pair. We have to express the pair. So what is that pair?
X equals to 2.
Yes. So I would say that 2 and 3. Yes. So yeah, x is equal to 2 and y is equal to 3. Yes. Thank you very much. But so could you guess, by the way, these numbers? It's not that easy to guess, but this is not guaranteed that we do not have any other pairs satisfying this condition. Is that clear? Okay, so you see, it's not that hard. Sometimes, let me see what I have written here. Okay, for example, another type of examples are geometrical problems. So let me read that one here. Find the height h and the radius r of a cylinder of the largest volume that can be inscribed in a sphere of radius square root of 3. Yes, so what does it mean? Let me draw a sphere of, say, radius square root of 3 if I can do it. So let us see how it goes. So assume that this is my sphere. Yes. Okay. And if I want to give you the feeling of that is the sphere, so let me just try to be a little bit artistic. Something like this, yes. Yeah, but this is very slippery on iPad. Yes. I don't know how people draw some very beautiful pictures using this slippery pen. Anyway, so here is your sphere. And what you're supposed to do, you want to actually inscribe a cylinder within this sphere. For example, let me give you a feeling of what I mean. This is one particular type of cylinders inscribed in this sphere. Yes? Okay, first of all, let me ask your opinion. How many of these cylinders you can inscribe in this sphere? Infinitely many. For example, I can make them thinner and longer. Yes? Or I can make them shorter and fatter. Yes? Something like this. Yes? So you see that I have infinitely many of these cylinders to put within this sphere. I want to fine-tune, I want to find the height and the radius of the cylinder with the largest volume. So first of all, do you understand that? This is my sphere. The radius of my sphere is the square root of 3, yes, everywhere. The square root of 3. And now I want to inscribe a cylinder within this sphere in the sense that I just described to you. And I want to have the cylinder having the largest volume. Yes.
Inscribe just means that the edges.
Inscribe means exactly what I tried to script. Defining it mathematically is a little bit hard, yes.
Yeah, okay, but that it touches the edges.
Yes, yeah. But in a symmetrical way, yes, because there is no. I'm counting on a symmetry because otherwise, hopefully, you feel that if I want to do it asymmetric, there is no way that I can inscribe it in the sense that you say. So it means that if this is the vertical diameter, I have to really be symmetric around that line. Okay, so I'm not going to prove this rigorously, but that's what it is. Okay, so how should I follow the problem? So these kinds of problems might be hard. The first thing that I do, I will draw a picture for myself for one of those infinitely many cylinders to know how to work with, yes? So for example, let us try to draw something. Yes? Yeah, so hopefully this will work somehow. Yes, it's not a very nice picture, but it's better than nothing. Okay, so that's my cylinder, okay? Okay, something like this. Okay, and now I want to maximize what here? What's the target function? The volume of the cylinder. Okay, if you forgot the formula for the volume of the cylinder, you can look at the formula sheet, but the volume is V equals to the famous pi number multiplied by the radius of the cylinder squared. Don't get confused, there are two radii involved. One is for the sphere, one is for the cylinder, and then multiplied by the height. Okay, but then again you have the same problem. You see that? What's the problem here? My target function is expressed in terms of two variables here. One of them is r, one of them is h, because if I change my cylinder, both of them are changing, so both of them are variable. In the previous problems, finding a relation between variables was more or less directly given in the problem where it was so simple. But here, you have to be a little bit creative to find a relation between r and h based on the geometry of the problem yourself.
So
Let me everyone think first. Is that understandable? So my target is now, momentarily, is to find a relation between r and h by the geometry of the problem. Okay, now I can hear from you. Yes?
well, I would say that the max height possible would be the 2.
But that's talking about the interval. We come back to that later. But first of all, I want to have my function. Still, I have partially my function. This is the target quantity, but it is expressed in terms of two variables. Based on the experience you had before, you know that one of them should survive in your calculation. So you need to find a constraint which is not directly in this problem. That is the hard part of the optimization problems. So by the way, I haven't used this piece of information yet. So that is there for something. By the way, I can accept everything based on symmetry. You don't need to prove everything really rigorously. Any ideas what to do? For example, from here to here is little r, and from here to here is h. How can I exploit this piece of information?
That's kind of what I was just going to say, that you know that if the height, let's say, is because I mean the height is as maximum 2 square root of 3, and the radius of the circle is maximum square root of 3 itself. So if
you need to find a relation.
yes,
You are talking about the interval again. Yes, Rasmus?
If we try to find a function to calculate h from r,
Yeah, what? How?
I would start by trying to imagine just if we slice through the sphere in the middle, let's say vertically, so we basically
Something like this.
yes, no on so that looks like we have a circle with a rectangle within it. That is the like.
Okay. So what you are saying is this, something like this. You slice it somehow here, and then you get a circle. Okay, I have to make the circle the same size. Yeah, but it is hard. You can pretend that this circle is one cross section, the biggest cross section of the sphere, and then definitely you will have the cross section of your cylinder as well. Yes.
Yeah, with the radius and
Yes. Okay. And then.
now I'm not really sure, but the probably.
No, you are sure. Actually, that's correct now. Because now this center of the sphere is also here. Do you understand what we are doing? We are cutting the sphere with the largest possible cut that we can have. Yes. But this is the. If I do that, so I just drawing. It's hard for me to draw it. So I have this plane. So let us say that this plane cuts the sphere from the middle, like an orange. Yes, you just cut it from the middle. And then that cut will also cut your cylinder from the middle. The cross section of the sphere is a circle. The cross section of a cylinder is a rectangle. So you need to imagine a little bit. So that's correct. And that's the center of this center is now here. Okay? And then we know that from here to here is H, and from here to here is R. Okay? How can I find the connection? What should I do? I need to draw one line to understand the connection using Pythagoras theorem.
Line passing through the point.
Yeah, from here to one of these lines. Yes? If I ask you, do you know the length of this pink one? What is that? This is the radius of the circle, which is also the radius of the sphere. Is that understandable? Because imagine you have an apple scene, yes? An orange. You cut it from the middle. You get a big circle in the cross section, but the radius of that big circle is the radius of the orange itself. Yes? Understandable or not? Yes or no?
It's going to be like r over 2 squared.
Now just tell me, is that understandable?
Yeah,
yes, that the radius are the same. Okay, so if that is the case, then I can cut this is square root of 3. But then can you tell me what is this length now? Rely on your intuition and symmetry. You don't need to be rigorous. If the height of the cylinder is h
over 2.
This is just h over 2. Yes or no? This is h over 2. Yes, this is this height. This is this one. So this is your rectangle that you see there. And this is this point. So from here to here is h over 2. From here to here is a square root of 3. And from here to here is how much? R, little r. And then you have your right angle triangle. Okay, so this is R. So I found a connection between these. What is the connection? R to the power of 2 plus h over 2 to the power of 2 is the square root of 3 to the power of 2. So this is 8 r to the power of 2, h squared over 4 is equal to 3. So that is my relation that I was looking for. Yes? I have to use this relation to eliminate one of these variables in favor of the other one. Again, for technical reason, it is important to think which one is suitable. If you want to eliminate one of them in favor of the other one, you look at the target function and look at your constraint. Which one is more suitable in this context to get rid of? R. Because why? R squared is already appeared in the problem. Yes? So if I write R squared is equal to 3 minus h squared over 4 and plug this back here, then I have everything in terms of h. If you decide the other way around, I hope that you understand you are really in trouble. Because if you want to do that, So you need to write h squared over 4 is equal to 3 minus r squared. You multiply by 4, it becomes 12 minus 4r squared. You take the square root, of course h is positive, you don't need to be worried about plus or minus, but then you need to put this back here, you get an equation of this 4, which is horrible to differentiate. Yes, and by the way, you haven't studied how to differentiate that. In Math 4, you will study how to differentiate this function, but even in that case, why should I bother to replace such a simple function with so complicated function? So these technical problems are really important. In the national exam, you will face some of these kinds of questions. So is that clear? Okay, so now I put everything, so not everything, I put this back here instead of r squared. I even didn't bother to calculate r. Yes, because I need r squared. So v is equal to pi. Instead of r squared, I put this expression in. So this becomes 3 minus h squared over 4. And then you see I have an extra pi h here, so I multiply it. And then I can safely call it v of h, because this is just a function of one single variable. But now I want to hear from you, Oscar, again. So this is my function. I also need to know my interval.
Yeah.
But the interval is also simple. What is the lowest possible value for h?
0.
0. And what's the highest one?
2 times the root.
Yes, 2 times the radius. Yes? So that's my interval. So h, of course, for 0, I know the volume becomes 0. And for the other extreme case, the volume becomes 0. So definitely maximum is not going to occur at the endpoints. But I'm just following the rules. Yes? Is that understandable why I brought 2 in? Because the highest possible height of the cylinder is the diameter of this one, which is 2 square root of 3. Okay, so now everything is ready. Hopefully we can actually calculate the problem. But you know that before doing that, I have to expand because you don't have a studied product rule. So what I do, I keep pi because pi is a constant, and then I multiply h in, so this becomes h cubed divided by 4. And then I differentiate. Yes? So what should I do? Pi is just a constant, I don't bother. And then it becomes 3 minus,
Well,
yes?
I think the brackets is to the power of 2 because r is.
No, that's the point.
Ah.
No, that is the easy part because I calculated r squared,
Yeah.
and in the formula r squared appears. And that's exactly the reason why it is better to get rid of r in favor of h. Okay, so that's what I'm saying, it's important. Okay, and then can you tell me from your head what's the answer to the derivative of that one?
Well,
It should be matter of seconds. I don't understand why you hesitate to say. Just tell it.
3 over 4.
3 over 4 h squared, yes? Yeah, so it is 3 over 4 h squared. And then I put it equal to 0. When I put it equal to 0, it means that 3h squared over 4 is supposed to be 3. So h squared becomes 4. H becomes plus or minus, but of course minus is not acceptable. So let me write it. Formally, we have to write both of them. But of course, the negative one is not within the interval. So I have 3 numbers to check. One number is positive 2. And then one number is 0, which we already know the answer to 0. The volume should be 0. And the other one is h equals to 2 square root of 3. Yes, now I calculate the volume for these values. H, V of 2, V of 0, and V of 2 square root of 3. We already know the answer to this with 0. The answer to this is also 0. But what is V of 2? So V of 2, I put 2 in my function here instead of H. Let us calculate this. Because if I put 2, it becomes 4. 4 divided by 4 is 1. 3 minus 1 is 2. And if h is also 2, it becomes 4. I have a pi here, so it becomes 4 pi. And then everything is in, okay, I haven't mentioned, so I can say the volume units. So this is the maximum possible value. But what is So here we are supposed to find the height and the radius, not the maximum quantity. So the maximum possible value is 4 pi volume units, but what is the dimension? So what we have to answer here, we need to answer for the height. The height is 2. And what the radius is, you take this 2 and put it here. It becomes 3 minus 1, which is 2. So r becomes a square root of 2. So this is square root of 2. So this is something we have to do if we want to have the cylinder with the highest possible volume inscribed in this sphere. Yes? Is that understandable? Okay, so I mean, these kinds of questions you also have in the book. So there are very good questions in the book. Yes. I want to stop here. We continue a little bit with solving some more problems tomorrow. But this chapter is completely finished now. So we can decide about exam date. Do you think week 11 is a good date? Yeah, you can, let me just pause recording. Any questions?